I was wrong yesterday about the faucets, and I'm sorry about that. I was thinking that we all had the same exact faucets to instantiate, and they're not the same anymore. Of course, they're not the same anymore. So Nelson, thanks again for just getting to the bottom of that. The access token changed, even though I forgot that these token names were part of the compiler right here. So I was thinking to myself, well, yeah, the token symbols are the same for the access token and even for the fungible token, but those names are different, right? This is not PPBL Summer 2022 anymore. Now it's PPBL 2022 access token. And for anybody who's new here, I just want you to know we launched this course in the summer, used PPBL Summer 2022 as the token name, but just didn't want to alienate anybody who's showing up now. So given the network respin, had a chance to rename that token, just so people know that this course is still current right now. Added a capital G here as well, just as kind of a convenience thing to tell the difference. And so that was one difference with my recompilation right here. And so this is how I compiled it, and this is what I added to the front end. And so that is new, and it's there and it's working. But then, as Nelson pointed out, when you try just one of the existing ones, obviously it's not going to work because this is not the name of the access token anymore. Any questions about that? So what we can do, I'm going to make some quick changes right now to the front end template just to kind of illustrate what I'm talking about. So let's go into the front end template. We've got a list of CBOR that has been shared via merge requests on Git. And I think it's safe to just remove these at this point. Any objections to me just, well, you know what? I'm not going to remove this yet because it's not getting in anything's way. I'm going to leave these here for now, but maybe clear out this folder later on, just in case there's a reason for any of these to still exist. But what we certainly don't need anymore is in this Plutus faucet list, we're no longer going to need all of these instances that have been shared, okay? So any objections to me just removing everything from this list right here of all these old contracts that don't work anymore?
Do it.
Clean up house, let's do it. And one of these is my new one, but I'll be able to grab that in a second. All right, so let's clear that out. But then I did recreate this one on the new, for the new implementation. And so this can be the first one in this new list right here. And let's just demonstrate this to make sure it works. So I've already got this project running right here. Oh no, I have the GBTE running, so I need to. Okay, here's the front end template, complete with some leftover GBTE styling. All right, so now if I pop into the mini project here and I check out the list, this is actually cool because we do see an extra ones. This is going to give us a chance to review how that revocation list works, okay? But first, oh, and you know what? I have not yet reloaded. I can't demo this right now because I haven't yet reloaded my pre-prod wallet onto this box that I'm working on. And I'm not going to take the time to do that right now. But if you do have a wallet hooked up that has the new access token that went out over the weekend, this one will work. Okay, this is a new instance of a faucet, but this is an old one. This one won't work anymore. And in fact, because of what I just deleted from the faucet list, that's another reason why it won't work. Even that old CBOR is no longer there. If anything about what I just said is not clear, please ask a question about that. But just to kind of take it for granted, okay, this is an instance of a contract whose logic worked when it was a PPBL summer 2022 token. Now it's not that anymore. Now, I encourage everybody to take a look in Discord where Nelson identified this message, because the other thing, the mind-blowing thing that I saw for the first time was a Plutus error in a web alert modal, okay, which is life-changing. We no longer have to wonder what Plutus error it is if those start showing up there. Now, I haven't confirmed this on my own yet, but just to know that that's out there, that's going to make a lot of development work easy, because we've been dealing with kind of the catch-all validator error for weeks now. And now we have the opportunity to actually read Plutus errors when we're working on the front end. And I hope maybe some people share my excitement about how nice that's going to be. Hey, why is this thing not working? I can actually see why now. So that's good news. But I'm sorry that I forgot that I didn't have my pre-prod wallet loaded onto this machine right now. So we'll come back to that. But what I do want to look at, accepting the assumption that this one's wrong, and let's look for a second. Remember, this list of components that's on this page is coming from our registered faucet page. And we just query for this metadata key right here, right? And so let me open up GraphQL for a second. And let's run this query for this metadata key. I just got to update that down here at the bottom. We should see two entries here. Okay, here's the one with the chili token that we were just looking at on the page. Here's the one with the T gimbal token that we were just looking at. And remember that metadata keys are kind of I think it might be fair to think of them as a commons. They're a shared resource, and there's really no way to ever stop anybody else from posting anything at a given metadata key, right? So one thing we want to be aware of is, sure, as a dApp developer, if I'm using this pattern of using metadata to represent the registration of an instance of a contract, maybe I'll make a mistake. Maybe somebody else will make a mistake, right? It goes without saying, I hope, that we expect that to happen, and we shouldn't be tied to a solution that has wrong data coming at us all the time. What we want to do is be able to have an answer to that. But then thinking about it from a different perspective, somebody could attack this metadata key, right? Other people could start using it for something else, and we just have to expect that that's going to happen. So what we want to be able to do is say, okay, yes, registration is on chain, and we want to be able to account for mistakes or wrong data in that metadata. And so what I can do is just take this transaction hash from the one that I don't want to appear. I'm going to copy that. I'm going to bring it over here and just add it to a list. And this is a really basic solution to this problem. There's other kind of more rigorous ways to approach this problem. Maybe you don't want the revocation list to just be in a web page, and that would be an acceptable thing to consider. But just to show you the concept, I'm going to put this hash right here. I'm going to go back over to the browser. And note, this is the hash ending in 4457. And so that's, you can see that hash right here, and you can click it like a link to look at it on Cardano scan. So there it is. But if I save my changes over in VS Code, that instance of a faucet no longer appears on the front end. Okay, so 2 steps. 1, query the metadata, everybody who's registered their instance. 2, if necessary, have a revocation list so that any data that is unacceptable for any reason is not included there. Who's got questions about that, or does that get you thinking about any next thing? Yeah, Roberto.
This is only purged from the front end, right? You're not really changing anything at the data level.
That's right.
Okay.
That's right. Because the data is immutable. Once metadata is on chain, there's nothing I can actually do about it, right? If I look at that key and I look at all the transactions that have ever had metadata on that key, I can't erase that. So I have to do this somewhere else.
So that's still accessible then?
It is.
As a component?
And this is the reason I want you to see this and think about it, is because this applies directly to self-sovereign identity. You kind of have to do a couple of mental somersaults to think about how SSID systems are going to work. But the core concept is, well, if I have an immutable data layer, how do I remove data from that? Right? That's kind of a hard problem, right? So any identity solution where, for example, decentralized identifiers or verifiable credentials are going to be posted immutably on chain, you must have a revocation list layer. You must have a way of saying, yes, I know that data is immutable, and here's the subset of data that I'm going to ignore from that list. That's a key part of SSID. Yeah, Nelson, that's a good challenge. Those are unlockable, right? You could build a transaction to unlock those. It's just not, it's not in the front end template anymore to do it that way, but it could be done from if somebody mints, well, I guess I have the policy key. So if anybody wants a PPBL summer 2022 token just for the purposes of unlocking Nelson's Chili's, we can do that. That's fun. Hey, Bernard. Curtis, what do you think?
Yeah, I was just thinking, I mean, this does introduce more complications, but the revocation list could be another GraphQL that says, okay, what was the minting transaction for this particular token that contains this metadata? Query the address associated with that minting transaction, and then look for the PPPL, or basically the access token. And if they don't have the access token, then it gets added to the revocation list. But I can't see the problem of, what if they move that access token to a different wallet? Well, then you're kind of screwed.
But so when you say something like that, I mean, I love this. This is where we're supposed to go, right? We don't stop here with these basic examples. My intention is for these basic examples to get you asking those next questions, and right, where all of us together are going to start thinking about, okay, well, how do I improve upon that system? How do I make it more robust? And those are great questions to start with. I want to come back to something else about that in just a minute. But first, Ron, what do you say?
Well, I was just thinking about the revocation list. Like, is that something, instead of like having a list of what isn't acceptable, like would it be better just to have the list of like what we are accepting, and then because then like if there's like somebody spamming like a metadata key, like wouldn't that be kind of cumbersome to like keep trying to update? I mean, I guess you could, I mean, like you just showed the example manually, but we could have something that's monitoring that, right? And then I was also like, you mentioned about the SSIDs, like that, because those are gonna kind of change over time, right? So then we're gonna have to be looking at like, so that metadata hash is obviously gonna change because it's a different transaction. So then you're just updating that. So that's gonna have to get updated on a list of what's acceptable anyway, right?
So it's on the one hand, it's like an interesting philosophical question, right? Do I want the gatekeeping element just to say, hey, everybody's invited except these ones, or do I want it to be like, hey, you have to be on the guest list, right? And so that's a design decision. Right. And sometimes either one might be the right decision. And then we can have other simpler things. For example, you can make a filter that's not about filtering out certain transaction IDs, but it's about filtering out just wrongly formatted data. So I could say, okay, look, we're using this key right here. This is the shape of the data we want, and we expect other people to use this key, perhaps. So in our application, we're only going to look at metadata that at least has this format. And TypeScript makes that really easy to do, right? If you define a type in your front-end template for what the bounty metadata should look like, any entry here that breaks those rules can be omitted from a list.
Gotcha. Okay, that makes perfect sense.
I think there's a lot more, in addition to software development work, there's philosophical work to think about when are we going to want this or that system. This kind of helps us. Yeah, I agree with that, Curtis, right? This is a good chance, and going back to what you were saying, Curtis, and this relates, Ron, to what you're saying as well. We're talking about gatekeepers here at the end of the day, right? Who makes the list of what can pass through? And that's what I'm really excited to get to today when it comes to thinking about bounty hashes and inline datum. Had some breakthroughs here. So we can come back to these concepts, but maybe you're going to see some of these ideas around lists of acceptable data when we start diving into the Treasury contract right now. But please, I'm going to start just taking you through this a little bit, but please stop me anytime. Just unmute and holler or raise a hand, okay? So closing out the front end for now. I'll need that open. All right. First of all, this is the faucet. We don't need that anymore. Just like in the course repo, GBTE V2 has been updated to use a Treasury issuer policy ID instead of a pub key hash. Okay, so that change is now implemented and it works. In our types, you can see that change represented as well, of course. What's new here and what's not in the current course repo is this Treasury datum, okay? So Treasury datum has not yet served a purpose. There's been a placeholder there to have some kind of custom data object, but it's just been waiting for us to do something with it. So I'd like to propose something with this today. I initially kind of started thinking with some people about this idea last week. What if the Treasury datum had a list of strings that represent these hashes of bounties. In the front end template, we're able to take the content of a markdown file and the number of reward tokens associated with it and use that to calculate a hash. It's a good solution. I think we need to look closely at how it works to make sure it's secure. But the idea here is, right, we're not committing yet to any logic on the front end. All we're doing is providing a hash that says, hey, look, if this bounty changes, the hash is going to change and people are going to be able to verify that. Okay. So what we have now is the ability to take a list of those hashes that our front end creates and store them in some inline datum. We then also can add a bounty hash to the bounty details, which is used in both the treasury redeemer and the bounty datum. Any questions so far about just where this data lives?
I do have a question, but I have a feeling you're going to get to it. So maybe I'll wait.
No, jump in. It helps me kind of direct where I'm going with this.
So you're talking about getting a hash and then using it as inline datum. And I can't quite see the benefit because isn't a datum already hashed and you could just see the hash of the datum without it needing to be inline datum?
Excellent. Okay, no, that's a really helpful question. So yeah, we might need new words to distinguish between which data is being hashed. Okay, so you've got the on-chain version of datum that can be used to create a datum hash that goes on-chain. That's one thing. But then there's another thing that's off-chain in our front end for GBTE that calculates just a hash of some markdown data, right? It's nothing about it is on chain. And the only purpose of that hash so far has been to allow contributors to verify that the rug's not being pulled on them, right? I'm committing to this bounty as it's written here for this amount of Lovelace and this amount of gimbals. And here's the description of that bounty. To freeze that description in time, we can create a hash of that information, right? Not an on-chain hash, just a hash. And this is something that predates blockchain, is just this ability to summarize data with some hash. Okay. This way, if a contributor commits to something, and then the issuer who says, well, that bounty was only in a front end template, nobody's going to notice if I change it a little bit. What if I make the Lovelace a little bit less than it was? What if I add a bunch of requirements right now that somebody committed to it? If that happens, the hash of that bounty is going to change. And the contributor is going to say, no, that's not what I committed to. It changed somehow, right? And I think there's really interesting ways to back up this data, but for now, we can even rely on GitLab to do that. You can go back through the commit logs and you can see, when did that markdown file change? Ah, there it is. What changed? Oh, okay. Well, if we undo those changes, oh, do we get that same old data hash or bounty hash? Yeah, we do. Okay, that's what it should have said. All right, so that's not I don't think that's a forever solution, what I just described, but it's a sufficient starting point, I think, right? This ability to just verify that the task still says what we committed to. So far, so good on that part.
Yeah. And I realized a couple of things as you were talking that wouldn't make sense to my question. So yeah, that makes a lot of sense.
Awesome. Trevor, what do you think?
Yeah, so just thinking through this, I know that there's manage options for the GBTE, which would be great for when something is still in treasury. But then okay, only issuer can change treasury, right? So then is there also a manage option for the escrow? And would you have to put in some kind of safeguard to say like, look, you can't change this once it's gone to escrow? I might have just missed that, but yeah.
Right. So that's where we're going. That's a fabulous question. So right now, we do have the ability for the issuer, and you can see right here, no longer identified by their pub key hash, but by their token. We have the ability for the issuer to update a bounty. Okay. And this is not yet using the new logic that I want to show you today, but it absolutely needs to be updated to represent this. Okay. So far, what we have is, yeah, the issuer can update. And what must they do? Well, they have to leave a bounty there. Okay. They can't remove that bounty from escrow without certain permission. Later on, they can cancel it after a deadline. Okay. And this is going to be another application parameter right here that people might need to think about. What is a fair amount of time? If somebody commits to something, can I cancel that in 60 days if they never do it? Right? We can't have those tokens locked up forever if somebody commits to something and doesn't get it done. So there's that deadline bit. But if before that deadline, I want to make an update, there's only two things you're able to do. Okay. You have to create another bounty. You can't just cancel it. And the output UTXO must have values greater than or equal to what was originally published. This is an opinionated decision, but I stand by it, right? If I'm going to update a bounty, I should not be able to make it for a lower amount of Lovelace. I should not be able to make it for a lower amount of Gimbals. If I'm going to be an issuer who can update a bounty, I should only be able to add more tokens to it, right? I can never walk back a promise I made. But if a contributor comes along and says, hey, yo, this is harder than I thought it was going to be, I think maybe it should be a little bit more. You can have a conversation about that. And if you come to an agreement, you can update it on chain. Now, what's not accounted for here is, well, if you change those amounts, then that would technically change the bounty hash. So that's a really interesting thing, I think, that we have to work with. But I think the first step to working with that is to show you how this works on the treasury end. And hopefully this will help all of us have some ideas for what would need to be changed right here. Curtis, what do you think?
Can the issuer cancel prior to the deadline? I didn't see the deadline has been reached, so no.
It won't let you, right? In order to cancel, the deadline has to be reached. You must be past the expiration time.
Okay. Because we did talk about the scenario a little bit, and I'm trying to see if there's a way around it where the person committing to the bounty realizes this is a much larger project and it probably should be broken up into, say, 3 smaller tasks. Since they can't reduce the amount of Lovelace on this one so that they can create 2 more, they need to cancel it and then create 3 additionals. But if they can't cancel it before the deadline, they're kind of stuck, right, with this one, and then they might not be able to split it.
Yes. That's right. Well, so, and that speaks to maybe there's room for another guard right here on cancel. And that would be, this is a wonderful thing to explore, right? What scenario can I add to cancel so that maybe something could be split? Or maybe it's a new action, right? Maybe in addition to canceling a bounty, I should be able to split a bounty. And these are things that I don't want to be the only decider about these things. Okay, so I would love to hear different people thinking about this, tinkering around with it. Yeah, what are some other cases that we might want to cover here? And I forget why it was removed, but one of the original bits of this contract right here was the ability just to extend a deadline. Okay, so one thing that the issuer can do is add more value to a bounty. Another thing an issuer, I believe, should be able to do is extend the deadline. I think I removed that just temporarily for simplicity, but it ought to be re-implemented. All right, so check it out. Let's come back to that, because I think what we can look at right now is going to help. I can speak for myself. This is helping me to have ideas about what goes here. I'm excited to hear what everybody thinks. So in the Treasury validator, there's now a new guard that says check bounty hash. All right, this is new since earlier. Now, B is the bounty details that's included in the redeemer if we're committing. And then when we go down here to check bounty hash, it says we take those bounty details and return a Boolean. And what has to be true? The bounty hash in B has to be an element in the list of bounty hashes. And what was dat? Right? Dat is right here. It's the Treasury datum. And remember, going back to types, Treasury datum has this bounty hash list, which is a list of byte strings, not just a single built-in byte string like it is here, but a list of them. So we can use the element function from Haskell wrapped in backticks right here to use it as an inlineable function. It would work just as well to remove the backticks and write lm like this. Okay, so either these two things are exactly the same. All right, lm this in that, or using backticks this inline approach. Okay. And we're saying the bounty hash from those bounty details must be an element of that list that's represented in the Treasury. Any questions so far? There are always changes on scope. Yeah. Yeah, John, yeah, I agree. So this is, we need to be able to account for updates to scope. That's incredible. Really important. Trevor, what do you think?
Well, I have a couple of thoughts. One, just on this subject of worrying about changes of scope. I think that a lot of that stuff is going to kind of play itself out as it gets used. But one thing that I think could cover a lot of that, if we're still working on a phase one kind of high trust environment, would just be to allow canceling, aka starting over, if both parties sign it. So you still have this, option for like, okay, something came up, we both agree, we can cancel it, but you don't have to like figure out every edge case before we've even really used it a lot. And that would kind of cover us for this kind of high trust first environment. But then beyond that, just so that I'm understanding this correctly, as far as the bounty hash, so then we're still working with a Treasury that kind of has a single UTXO, right? And so then just every bounty that's in there gets added to this list of bounty hashes. And that would probably be true then even with this new version that allows us to use tokens, right? To have issuers. Every issuer would just add their bounty to the list of all of them. Is that correct?
Every issuer would add, yes, right? So there's going to be a list of however many bounties are presented on the front end. The Treasury's datum is going to be that list. So let's take a look at what that looks like. Okay, so now we've added this, it compiles, and I've got some transactions to show you. actually, before we get to those transactions, let me show you an example of what this datum can look like. All right, so this is an example of treasury datum. Here's the token name of the issuer token. If there's only one issuer token, well, this is always going to be the same. If there are multiple issuer tokens, one way to think about this string right here is this is the most recent issuer to update the treasury. All right, that can be one way to think about it, but I'm sure we're going to surface other ways to think about this. And I could imagine this too being a list. All right, we could just wrap token name in brackets here and change our contract so that issuer token name is actually names and a whole list of those. So a few different ways to extend this, but for now we're handling the base case where there's just one, or most recent, either way you want to think about this. And then here's the format. Again, this is the JSON that will be attached to the transaction. Okay, this is the JSON for having a list. We have a list, brackets around it of objects. The key for these objects is bytes, just like it is here. And then we're going to have each of those strings that we want to represent. Any questions so far? Okay. So here's these new contract addresses. I think that was most up to date. All right, the escrow contract is currently empty. The treasury contract has a single UTXO in it with some Lovelace and some test gimbals. By the way, I wasn't prepared for this, but it was thrilling to see. I could see the actual name of the treasury token right here in the inline datum. Okay, so again, look at what my datum looked like. It had the hex string for my issuer token, but then I posted this, and I'll show you the transaction that created this in just a moment. But once I posted this datum right here on chain, 5472, et cetera, notice 5472 as a test string is what I used here, and 6173 as a test string is what I used here. So check it out. When I go to the inline datum, those hex strings are translated. So the token name is actually readable right on chain and inline datum, pretty dope. And by the way, 5472, that's the first two letters of treasury issuer example, TR, and AS are the next two letters. Okay, so it's going from hex string to human readable as it puts it on chain and inline datum. That I wasn't ready for that part this morning, and I think I shouted out loud when I saw that. I was pretty excited. Any questions about what I'm showing you right here? So then if we've got some data locked up, I also locked it up at a reference script, but I still, I'm still waiting to see the use case for this UTXO right here. Nobody showed it to me yet, and I haven't figured it out for myself. I've got inline datum in a UTXO that's not attached to a contract UTXO, and I haven't yet figured out what that's good for. Maybe in an exploration of CIP 68, the answer will emerge, but I encourage people, try to figure out how to use something like this. And that would be a fun thing to share with everybody else. But then I also have two reference scripts here. Okay, just in case anybody hasn't seen this yet, I want you to take a quick look. At this reference address, if I create an out file with these UTXOs, right? It's gonna actually give me a file that I can open up because I can't tell that this has anything special about it. It looks like it just has 19 ADA in it, right? But if I actually get the out file of these UTXOs and look 7259C, index 1, let's just look at those UTXOs. And this top one, right, matches this. And it has a reference script in it. So I think a lot of people have seen it at this point, but if you haven't seen it yet, this really helped me to understand, okay, it's just CBOR hex, now it's on chain in a UTXO. Just read 68, that's it. Any questions about this right here? PlutusV2, by the way, right? Specified.
There's nothing in the address or anything in the data that indicates that it has a reference script, right? There's nothing like address 1, address something.
Not that I'm aware. But maybe there's a new use case for ADA handle, right? Maybe I want to slap an ADA handle in a wallet that I use for reference and just give it a name. Gimbal Labs reference scripts or something. Somebody buy that one. Start throwing reference scripts up there, okay? That's one way to think about it. And I'm sure there'll be better queries moving forward to help us look at these. Trevor, what do you think?
Sorry, just catching up a little bit. I was just looking through the code here, and I remember we looked at in a previous live coding session the version 1 of the GBTE, and we've been talking about that. And I know you used the access token or the issuer token for issuing on that one. This one is still public key hash, isn't it?
Yeah, I have not pushed these changes up to GitLab yet. Sorry about that.
Okay, no worries. I just want to make sure that I'm following correctly and seeing what I'm expecting to see. Okay, cool.
I'll push the. Sorry, I meant to get to that this morning, but yeah, I'll get to that right after this.
No, you're good. You're good.
Thanks, man. So we've got, and then this one down here, 2BFA1, also has a reference script on it. And then notice this was interesting too, right? So if I look on the CLI view, I have a nice human readable token name right here. But if I download the UTXO's JSON file, that inline datum looks just like it looked in my VS Code editor with the hex strings. So that was kind of a neat thing to see as well, I thought. Let's use some of this data. So remember, there's a couple of transactions that we want to do. I want to look at committing to a bounty right now. So a couple of variables. We need the treasury address and the escrow address because this commitment transaction is going to pull funds from the treasury and place them in escrow. We need that reference script that we were just looking at in my terminal window. And then we need a couple of different datum files. We need the one for the treasury itself. Oh, you know what? Actually, I don't think we need this one. Let me comment this out and get back to that in just a second. We need the treasury action, which looks like this. Constructor 0 up here represents commit. And then the fields has another object in it that has constructor 0. And this is our bounty details. There's the byte string right here, okay? I'm kind of moving quickly through this part because I think we've looked at it already, but stop me if you have questions about this part right here. This is how you use a parameterized redeemer, right? Commit to this bounty, commit B as it looked like up here. Then the other thing we need is where's that file? The other thing we need is a bounty datum file. This is going to be the datum that's attached to the escrow UTXO. We'll look at it closer in just a minute, but it looks like this. It's very similar to the Treasury action, but it doesn't have this constructor around it. It's just the data itself. Whoops. Right. Because datum doesn't have that action word associated with it. It just has the data. So both of those are going to be used in the transaction with the asset that's specified at compile time. This is the test gimbal on pre-prod. And what I'm trying to do with the scripts that are being uploaded here for you to play with is not automate everything. Okay, so there's a bunch of prompts then here that we can look at. Just to remember, I want you to get a feel. I want to provide scripts so you're not just copying and pasting from Markdown, but I don't want you to be able to load up a script and have it work just like that. I want you to have to like look at it a little bit so you get your hands dirty. Okay, so let's use this one right here. It takes 2 command line arguments. It takes the address of some contributor and the signing key of that contributor. So I'm going to say run script 02. I have the contributor's address and key just saved as variables right now. So this queries the contributor's wallet first, and we need to find the UTXO with the contributor token. Contributor tokens have this policy ID right here, 738. So that's the UTXO I'm looking for at index 2. Every one of these has a unique asset ID, right? Same policy ID, but different name. So that's the one I'm going to use. For collateral, 5 is more than enough. For fees, I just have a habit of using my biggest UTXO. It doesn't have other tokens in it. And that's all we need from the contributor. So now we look at the treasury address. And the treasury address has only one UTXO in it. There's this much Lovelace in that UTXO. There's 9,000 test gimbals in that UTXO. And then we got to think about the bounty. Okay, so this part was written over here. In this bounty example, we're just saying, okay, what if it's 5 ADA and 500 gimbals? And then down here we've got this. This is supposed to be one of the bounty hashes. It's just a very short string for now, just to show that this works. Let's see, is 5472 in that list? Yeah, it looks like it is. So just to mess around for a second, let's change the bounty that we're trying to create. Let's change this string right here to something else. 453A, something random, okay? Not something that exists in the treasury datum. I'm going to save that. Okay, so I'm going to use 5 ADA and 500 test gimbals because that's what the redeemer is asking for. 5 million Lovelace, 500 gimbals, and check it out. Here's the error that was just added to that Plutus script. We get not a valid bounty hash. So I'm going to go back and do this one more time. But before I do, let's just go undo these changes right here and use a valid bounty hash. Save this once again. And you know what? Just because I think it's helpful to look at these mistakes, let's use a wrong amount of gimbals this time, just to show you that other errors will show up. So these steps, just going to quickly jump through these again. And I really recommend trying to see each error, okay? If you're ever playing around and testing a contract, see if you can get every single one of those trace if falses to express itself on the command line. And that's what I'm trying to do right here, is just look at one more of those for now. Treasury UTXO. Okay. How many Lovelace in the Treasury? That many. 9,000 test gimbals. Now my Redeemer says 5 ADA and 500 T gimbals. But what if I accidentally wrote like 400 gimbals, for example? Oh, I forgot the hash right here. Sorry, no, that's worth doing again though. Sorry about the delay here. I want to see a more meaningful error than that. Remember to use the 1 this time. There's this many. Right amount of Lovelace, not enough gimbals. That's more like it. That's what I expected. Output value must match bounty details. So just another example of making sure that those errors are popping up. I'll leave the rest to you to try to replicate, okay? Because there's a few more in the Treasury validator that are worth exploring. So let's do everything right now. Remember, I already went back and I changed the bounty hash to be a member of the list that we can see right here. And so let me run this one more time and specify the right amount of test gimbals. Commented out in the script files, there's variables, so you can change each of these variables right there in your script file, so you don't have to do this cutting and pasting that I'm doing. And you can just run this script a bunch of times by just playing around in the script itself. You would just comment out all of this user interaction right here. Treasury UTXO. Lovelace. Gimbals. 5 ADA and 500 gimbals, and we're fine. Okay. By the way, using reference scripts, we've got a transaction fee of less than half an ADA. Running this same transaction right now with a Plutus V1 script costs about 1.5 ADA. So a full ADA savings by making this change. Any questions at this point? I was going to wait for long enough for the transaction to be accepted, but it looked like it already happened. That was quick. All right. Pre-prod is humming along this morning. So if I query these addresses again, now the escrow address has a UTXO in it, and that UTXO represents the commitment I just made. 5 ADA, 500 gimbals, and my access token. So how about unlocking this? This is a pretty trivial one. It hasn't changed much, except it is using reference scripts now. Okay, so this is our reference script for the unlocking transaction. Let's take a quick look at what that looks like. You'll be able to find this in the repo as transaction number 3. Looks like I need to open it again. Here we go. Here's our reference UTXO from the reference address. We're just looking at this. Same bounty asset. We don't need the treasury address this time. All we need is the escrow address. We need a redeemer that just says we're going to distribute. This is a trivial redeemer where all that matters is the index. All right, so here's distribute.json. Bunch of prompts once again, so we make sure we get our hands dirty. But right down here, this is the important part, okay? We're going to try to consume the TX in from the bounty escrow address. No matter what bounty I'm trying to unlock, there might be many UTXOs in the escrow address, but all of them refer to the same reference script, right? Same contract logic for unlocking. I have to tell that it's a V2 script. The inline datum is present. That's this right here, right? We've got inline datum. So we don't have to upload any additional datum. All we have to do is say that it's present. But the action file, the redeemer action file is not on chain, distribute.json. So we got to attach that. We're going to need a couple of TX-ins, just one for fees. That's TX-in1. We need the TX-in that has the issuer's token in it, and then one for collateral. And then where do the outputs go? A couple of places. The contributor gets the bounty reward and in both Lovelace and in native assets. They also get their contributor token back. It would be easy to add this bit right here instead, but that leads to the inconvenience of your contributor token being wrapped up with some T-gimbals or whatever other native asset, which can just make it more difficult to manage later. And in a user's wallet, that could lead to some hiccups with a browser wallet when you're interacting on the front end. So I'm choosing to keep these separate by putting this here. So the contributor is actually going to get 2 UTXOs, one with their reward that they were going to get anyway, and then another where they get their contributor token back. And hey, maybe when they initially made that contribution, the contributor or the commitment, the contributor providing the min UTXO was painful for them. Maybe they didn't want to spend that 1.5 ADA. Well, now they get it back. So they get the bounty reward in ADA, but they also get 1.5 ADA back as a min UTXO along with their contribution token. Dagwell and then A, what do you think?
Yeah, would that provide a hiccup if, like, let's say you wrote your validation logic to have that as 2 separate steps? One of it would be like distribute the tokens, and then another step would be to make sure that the contributor token goes back to the user. If you put that all in one line, would that screw up the validation, or would that still pass validation?
Great question. Totally works. Yeah. And I've seen it work a bunch of times, but then I end up pissed off the next day because I then have to break apart these transactions. I just want the contributor token, but I got all these T-gimbals in the way. So
Awesome.
I've been annoyed by it enough times to prefer this solution, even though the other one works.
Cool. Thank you so much. That's awesome.
You bet, man. Hey, what do you think?
Pretty much, I was going to ask the same thing, to be honest. Yeah, so I mean, so basically it's an opinionated thing. Like in the future, if someone was to, end up messing it up, it's not going to break. Okay, cool.
Yeah. And, actually the GBTE front end is built this way too, but it doesn't have to be. right? Most wallets at this point have put enough effort into improving coin selection that it's unlikely to lead to a hiccup if you're using a browser wallet. But I think a lot of us here might have some battle scars from using earlier instances of browser wallets and getting all sorts of UTXO errors. So I still have this habit from the old days that I'm carrying with me, and maybe I'll leave it behind eventually. All right. Any other questions about this distribution transaction we're going to try to build right now? I'm going to show it to you in action. And then if you have questions while that's happening, let me know. This one, oh, by the way, I should have showed you this. This one only takes one command line argument, the contributor's address, because just for my own convenience here, I just hard coded my key and address into the script. Okay, but you might want to adjust those on your end. So this is number 3, distribute. And I'm going to use the contributor's address again. What do we got to do first? Identify the bounty. And I want you to see this because this is what your front end is going to need to do. It's unlikely that there will be just one UTXO here. There's going to be one for every current commitment. We got to find the one that represents this commitment. Okay, so the front end is going to handle choosing which one. It's probably going to require looking at a Koios query or a Dandelion GraphQL query to help out with that. Okay, but for now, yeah, we want this one. How many Lovelace are in it? That's easy. That's right there. Cool. How many T gimbals? I'm just going to copy that number from right there too. What's the asset ID of the contributor token? These are all things that your front end is going to automate, right? But every step I'm showing you right now must be considered on the front end as you're grabbing this and that token, and that information is going to come from different places. Then we look at the contributor's wallet. That wallet needs to provide collateral. And as you guys have showed me, that can be the same one as the TXIN for fees. I appreciate that. And then we need, oh, sorry, I said contributor's wallet. We are looking at the issuer's wallet right now because we're distributing, right? The contributor doesn't have to sign for anything. They're just waiting to get paid. This is the issuer wallet. And so the issuer, in order to distribute something, has to have the issuer token. I got this one right here. So let's use that UTXO. In the same way, there might be multiple different token names for issuer tokens. So we got to specify which one. Policy ID is not going to change in an instance, but the name of each token might change. And there we go. Once again, less than half an ADA for a transaction that on PlutusV1 would have cost about 1.5 once again. And that worked out. Any questions about that? Yeah, Nelson, that's the critical point. We got to keep reiterating that for people, right? You don't like something you see here, the code is open source. Tweak it, change the rules. You see an opinionated decision that doesn't work for you, perfect. Grab it, make it happen. I love it. Yep. Cheap living in the Babbage era. It's cheap living, but somebody has to lock up all this ADA to have those reference scripts. Okay, so there's a linear function. In order to pay for this, I gotta save that much ADA 20 times, right? To justify putting this reference script online. If I'm only going to use it once, this wasn't actually that much cheaper because there was the transaction fee for creating the reference script in the first place. That was about 0.3 ADA. And then there's this 19 ADA that's got to be locked up. This can be unlocked anytime. But once it is, that reference script doesn't exist anymore. And so there's whole new dynamics. I don't really understand all the implications of this, but I've been thinking about it. and wondering what different people think about those new rules. What else comes to mind when you see this? Yeah, exactly. So Dagwell, if you do play that, right? If you say, okay, it's actually funny, it almost costs exactly the same thing. I don't know if the people writing cost parameters were taking this into account, but think about it. I lock a reference script, that's one transaction. I use it, right? That's our actual interaction transaction where I'm getting the savings. And then to get it back, I gotta unlock the reference script, which is a third transaction, which is gonna be a minimum fee, right? So now you've got the 0.5 or so ADA for the interaction itself, the creation of the reference script for 0.3 and a min fee. It's still less. Yeah, that would still add up to less than 1.5 ADA, but it's not remarkably less. Okay, so actually you will still save ADA on transaction fees if you use a reference script just once. I don't know if that generalizes. I might want to double check my math on that. Yeah, and there's a hassle. Exactly. All right, once again, stop me if you got questions, but I got one more thing now to bring to the table. Let's look at this. First of all, this is just a proof of concept right now. These strings in my treasury datum are not the byte strings that I actually want to be put in, or the datum, excuse me, I'm getting confused with all the terms. They're not the bounty hashes that it was my goal to put on chain, and I got to get those, okay? But this generalizes. It is likely that you're going to want to update the datum right here, right? The list of bounties is going to change. So when we talk about treasury management, let's go back to the Plutus over here. Treasury validator. There's this manage bit. And anybody who has an issuer token can manage this contract. One goal you might have if you're trying to manage a treasury contract is you want to just drain the treasury. Okay, that project has run its course. There's still some Lovelace there, and I just want to take those out so I can use them for the next project. Okay, no more bounties. Treasury closed. That's one thing this allows. Another thing treasury management allows is I want to add tokens to a treasury, but maintain just one UTXO. I can spend the UTXO that's currently at that treasury address, add more tokens, and create a new UTXO at the treasury address. Finally, if I can do that part, right, create a new UTXO at the treasury address, it stands to reason that the other thing I can do is update the inline datum at the treasury address. And that means being able to add as inline datum a new list of bounty hashes. Do we know if you can recollateralize? Are you talking about people's use of a reference UTXO? I'm not sure what that's in reference to. Limit access. Happy to hear more about that one. That sounds interesting. And yeah, hidden data. There's a few different ways, right? Maybe inline datum isn't always the right choice, right? If I want to use, I can use what I'm showing you right now, but it doesn't have to be publicly visible like this. I could just throw a datum hash on this UTXO and keep these details they wouldn't be secret in that case, but at least they're harder to see, right? You'd have to reverse engineer that datum or get it from somewhere else. So yeah, there's reasons not to use the inline datum approach sometimes. Nelson, what do you think?
So here for the manage part, the new situation comes in for the case where we have multiple issuers, right? We're distributing issuer tokens. So someone can lock in and another issuer can take it out.
The name of my issuer token that I'm using is right here, right? So another thing we can do is, okay, you need to know the name of the prior issuer. And if it's inline datum, you can just see it right here in order to unlock this UTXO in the first place. But maybe when we build our front end, we could make it so that this token name is updated to whoever the last person to interact was. That doesn't have any impact on the validation logic, at least not right now. And that's not a required decision to make, okay? So previously, this treasury datum was 100% a placeholder. Now it's not anymore. This list right here has a real purpose in the treasury validation. This part right here is still a placeholder. Okay, this issuer token name is not yet used in any way for the validation. So it's here. I wanted to include it just to kind of give everybody rails for thinking about what you could do with this. Okay, but it's currently not doing anything. And we could record whatever token name we want right here. And maybe front ends are one thing that we just use to do that informally before it moves over to logic.
So if we can somehow save how much issuer token have issued in the treasury, then he can be allowed to take that amount only from the UTX. So that can be a validation logic, right?
That's cool. Okay. So there's two issuers in a treasury, and each one contributes half of the tokens to that treasury. And each of us issuers, our decision-making power is limited to the half that we put in. So we can only distribute, and you can keep track how much Lovelace, how many gimbals have I distributed. Once it hits that half mark, that's the other person's turn. The other person's going to have to distribute everything else. Am I hearing you right?
Yeah, that sounds right.
That's really interesting. I like that. And right, that leads to likely unforeseen consequences. And I would want to kind of chew on that potential for a while, but at a basic level, that makes sense. Yeah, it's probably worth exploring. That would probably involve adding a field. Maybe you would add something. You could do something like this to the datum, where there's a list of ints where each int represents like the total number of gimbals that each issuer has given away so far, or something like that, right? There's ways to play with this, but what a cool thing to explore. Yeah, how can I use the datum to kind of track the relative progress or the relative decisions of each of these issuers? Neat. Okay, and yeah, back to that question, I don't know, right? But I have not yet seen a way to hide reference scripts from outside parties. If I'm using a reference script, people can look at it. But does an access token protect us against that. Okay, you can look at my CBOR, but you can't do anything with this unless you got the access token. Right, okay, and this part is also true. And I don't, this has felt like a problem to me for a long time, and I don't know how much of a big deal to make out of it. But remember earlier in this session, I mentioned that anybody can put anything at any metadata key. There's nothing stopping anybody from adding any metadata they want to the 721 key, for example. If it's wrongly formatted, will it show up on PluPM? No, it won't. But can anybody stop me from dropping whatever I want on metadata key 721? No. The same is true with addresses. There's nothing that can stop people from sending stuff to a given address. Contract address, wallet address, etc. But this is why the min UTXO exists. If you want to spam somebody else's contract address, you could, but it's going to cost at least a min UTXO for every one you send there. So that's what the protocol can do. But hey, if it's ever worth that cost to gum up somebody's contract address, is that a viable attack? Mm-hmm. So what do we do about that? Maybe nothing. Maybe just be grateful that the min UTXO exists. But maybe I have a feeling there's more to it than that. Because if there's $1 billion in a contract, somebody's going to try to screw around with it. It's going to be worth a couple bucks to screw with that.
I feel like there's some kind of like solution that, even in the minting solution, that filters the UTXO before it goes to the contract. So it's like you can't even get to the contract unless you have certain parameters met. And I'm not saying that's great for everything, but I'm just saying like having the contract address to me as the front facing contract that the people interact with, I just don't like that. I wish there was, I prefer there to be some kind of filter method. Like if you hit this, then we can send it to the contract. That's where I've been at lately. And I don't know if that's good for every situation because I'm running in, because then you have to filter the UTXOs that come in. And that's already, so just something I'm thinking of, man.
On mainnet, you can't hide an address. You could not tell it to anybody, fine. But as soon as that address has made a transaction, it's on a blockchain explorer. See you soon, Curtis. Right? Somebody finds that address. I can't stop them from knowing that address. But here's where the plot thickens. All right, side chains. All right, Hydra heads. Okay, how do I keep something private? I take it off the main chain. And that's, the reason it's worth working hard right now is that Plutus works on side chains. Plutus works on Hydra heads. And we better be ready for those things. We should probably be playing with Hydra heads already. Okay, so there's so much fun to be had with this stuff once we get these basics. Yeah, let's figure out how to use Hydra to keep some things a secret, for example. John T, see you soon.
Quick point here that I've been thinking about ever since it occurred to me. I mean, it's a weird thing because the actual ecosystem treasury, I'd forgotten that it doesn't have a UTXO, right? So as stuff goes in there, it's basically sort of, as ADA goes in, it's reborn anew. And that's, I was having this conversation with Roberto and it sort of reoccurred to me. And so I've been thinking, actually, there's a lot of value in doing something like that, given that everyone else creating a treasury, they don't actually have that privilege. So if possibly the interacting or interweaving of Ada and Ergo, given that you've got mixers, etc., and Ergo, that might be a possibility to create a way that in your treasury you basically are able to have fresh Ada, so to speak.
So thinking about this and thinking about these problems leads us directly to thinking about some advantages of maybe cross-chain solutions. That's mind-blowing. And this is the second meeting I've been in today, talking Ergo cross-chain solutions. Ooh, something's in the air right now. So the thing I haven't yet tested, and maybe what I'd like to do, I could test this live right now. Okay, pausing just for a second. We're at meeting time. A few people have dropped off already. I can stick around. And by the way, fun news, Santiago, the creator of Demeter.run, is stopping by this Zoom room in 25 minutes to say hey and to talk about collaborations between Demeter and PPBL. So if anybody wants to just hang out and say hey to him, you're welcome to. I'm happy to stick around here until that time to just keep hacking. So stick around if you want to. Juan, what do you think?
Hey James, this is great. I mean, I just said it. We need to learn this before to start playing with heads, because that's what is coming. And I wanted to mention that Prior is on the audience. So awesome to have you here, Prior. I don't know, you notice.
Who?
Prior.
Oh. Hey.
Yo, dude, what's going on? Oh, it's been forever, man. Hey.
Yep.
Yo, no, I didn't. Hey.
You just say this is gonna be the reunion. That's awesome.
Yeah, what year is it right now? Yeah. Ron, you haven't aged a day. What's up, man? Good.
Thanks. How are you guys? Hi.
What's happening? How you been, brother?
I'm doing fine. Thanks. Just hustling. Yeah.
Are you a full-time Plutus dev at this point?
Not yet. I haven't reached this point yet. Do you guys?
Oh yeah.
I'm not sure what it takes to satisfy that role, so we're good.
My hair is growing though.
Hey, all good things. Is it okay if I well, actually, okay, two things we could do right now. There is one thing I want to throw at people just to think about updating this data right here and to show you what will be next for me, to invite you to do the same. But Sarah, I know that your mic's not working, but are you interested in sharing screen right now and troubleshooting? You can just kind of work through it, and all of us can kind of coach you through and try to figure out what's going on. If you're into that idea, just say so in the chat and we can make that happen. Yeah, let's do it. Let's do it. All right, I'm going to close out here. I'm going to push these changes, and in the README, I'm going to publish section 7 down at the bottom, updating Datum in the treasury. I'm not done with this yet, right? But I think you should be able to manage the treasury and then just take the prior inline datum and then create new inline datum at a treasury if you are an issuer. So that'll be up there in the docs, and everybody's welcome to play around with that. I'll also publish a note on Discord when this is tested successfully. I just want you to know that that's coming up. Juan, is that hand up again? Can't tell if it's still up.
Oh, no. It was, I pick up.
All right. So, Sarah, I see that screen share has started. It's not coming through yet. Anybody else seeing it yet? Yeah. You want to try one more time, man? Stop sharing and then start again, see if it works.
I could see something. I mean, it was a VS Code screen, but I wasn't sure whether
Oh, really?
everything was.
Oh.
Yeah, I mean, at the top it did say Strateg's screen,
Okay.
but I'm sure whether it was just saying that at the top and you know, it's still showing your screen at the bottom.
Can you see it now, eh?
I can. It's black. It says you're
Yeah.
viewing Strateg's screen, but it's just black.
Yeah. Yeah, I'm not seeing it. Darn it. Okay, so instead, let's do this.
It might be a browser issue, perhaps.
Could be. Could be. Yeah, I wonder if it's the same. I mean, if you're not getting sound, I wonder if it's this. Oh, wait. Hey, there's something.
Yeah, we can see it now.
All right, that looks good. Okay.
Yeah, it might have been a browser permissions thing.
I'm pulling up also next to me the Discord chat, just so I can review what we've been talking so far. All right. So there's been a couple of errors with minting, and this worked before. So the first thing I wanted to do, Sarah, can you echo the address? Oh, I see it's Minter. Can you just query the UTXOs at that Minter address? Great. So you've got enough lovelies to do this. Perfect. And so your TX in, you're using AC362D. Yep, that looks good. So your TX in is not the problem. That's great. Your token name is set up. And then you got this policy script. Do you have that open somewhere? Good. Okay, so the key hash here, 108F is what it starts with. So now let's go back to the CLI. And the first thing I want to check is what's the pub key hash of that Minter address, right? This wallet we're looking at right here, the Minter is going to sign. And so what we need is Cardano CLI address. Key hash. It's key dash hash, sorry. And you can just press enter here to remember that what we need is now a V key. Okay, and I'm pretty sure it's going to be payment verification key, but just press enter so we can see the docs. I don't know if we lost you there. Okay, so if you want to just keep going right here, that's fine. It's going to be space dash dash payment dash verification dash key dash file. Well, see you soon. Yeah, good. There you go. And then we need the payment.vkey file that's associated with the minter address. All right, so wherever you derived that minter address from, find the path to that vkey file. Ron, man, thanks for being here today. See you soon.
Definitely. Yeah.
All right, look at this. Okay, so this key hash is not the one we see in the minting policy. And this is the critical thing. This is perfect. So this is actually going to be easy to fix now that we're seeing this. If you go back to the minting policy, the pub key hash there is different from this one. And Sarah, I'm not sure if you can hear me or not right now, but thank you for being patient with the internet connection. Really appreciate you doing this. While we're waiting for the sound to come through here. Okay, good. All right, good. So open up, you can hear me. Go back to the minting screen. Yeah, exactly. Okay, but here's the problem. If we change the key hash in the minting policy, it's going to change the policy ID. So this is fine. You can change that minting policy, but now you got to get the new policy ID. Now that key hash is different. And so you saved the file policy.script. You can use Cardano CLI transaction policy ID. With script file. And you had it open there in VS Code. I forget your file name for that script, but it's going to look like this: Cardano CLI transaction policy ID -- script file, and then the name of that file. Yeah, policy.script. Good. So it's what I just shared in the chat. And at the end of that, just write policy.script. That looked pretty funny. That freeze. I'm gonna do this. Oh, all good. I get that. And it's lowercase ID. So when you say Cardano CLI transaction policy ID is all going to be just one word. Yeah, like it is right there. And it was policy.script, right? Nice. Okay. Okay, good. So now with that policy ID, the transaction should work as it is. So now there's only, and just to pause right here, this is critical. So often the policy ID might come from a different set of keys than you're using to actually hold tokens. It doesn't have to. What we're doing right here is creating a policy ID from the same credentials that are holding these tokens in that Minter wallet. All right. But on the other hand, if those were separate, that would be another reason for needing two signatures. And so I said this in Discord, like if you have multiple signatures, this would be the solution. But here's another case where this is going to happen. If you kept the old policy ID with that other pub key hash, you would need two signatures. You would need the one, the signing key file payment.s key that you've already got to sign for Minter, and then another signing key file to sign for that pub key hash that was minting the tokens. Okay. Now we've eliminated that problem, and we're saying, look, we're going to use the policy ID that already comes from this wallet. Let's just do it. And so this should mean that you don't need any additional signatures, but you can get away with using just one. All right, so it's building as it was before, but you've made it this far. Let's see if we can get the last 2 steps in now. Sign, no problem. Come on, submit. Let's see. Ah, darn. I see the key hash it's expecting is still 108F down there. You changed the policy ID. Are you sure that's the policy script path? Because for some, or is that file saved? You did save it because we got a new. I'm just wondering why we're still seeing key hash 108 when that's not what you had in policy.script anymore. You changed it to 64F. If you undo that change, you'll see that it used to be 108, but it's not anymore. Ah, yeah. That's it. Good eyes. Okay, that should make a difference. Beautiful. Come on. Build with that just updated signer hash. Okay. Sign it. That's still going to work. No problem. Let's see it. Come on. Hey, we did it. Nice. Yeah. Hey, dude. Okay. So next challenge, try to get this to work by separating your token holding wallet from the policy ID. Okay. So go back to that original policy ID, keep the minter address, but now try to get it to work with a different policy ID with some other set of keys, and practice using those 2 signers there, okay? I'm glad that worked, and with a little time to spare. I like it when that happens. Cool. So like I said, I'm hanging out here to check in with Santiago. He's got some ideas for PPBL. Stick around if you want to. Yeah, now the mic part. I don't know. That's much harder than writing transactions.
All right, guys. Thanks for letting me listening to this. Yeah, I hope I can join you guys once again next time.
Be in touch, brother. Okay.
Thank you.
And if you want to catch up anytime.
So thank you. All right, guys. Take care.
I'll hit you up. See you. By the way, Alpine and Dagwell, I'm pumped about the stuff you're working on, Alpine, and it will be really interesting to kind of run a live coding session, or maybe write a little module for people to kind of start to understand what you're building on the front end to capitalize on some of this back end stuff about reputation building and bounty completion. How you feeling about how that's going so far?
Hey, gents.
Sarah, whoa, we can hear you.
Hey, yeah. Sorry about the mic situation of this new Linux machine. I'm not even sure if it has any support for a mic.
Thanks for your patience on that, man. No, that's a big headache. We're working through that. Cool.
Can you hear me? Yeah.
Yeah, I can hear you. Yeah.
Okay. Cool.
But hey, we're
so
gonna.
What was the last part you said about? Okay.
Oh, sorry. Just really quickly. What you just did is you successfully minted tokens by using a single address, the same key pair for both sending tokens, but also for the policy ID to mint new ones. Often people are going to separate those two concerns. Mm-hmm. So it's worth it to understand, okay, look, I got funds in this wallet. I have to sign for those UTXOs. But then with a different set of keys to derive a policy ID, if you do it that way, which is best practice, you're going to want two signatures on the minting transaction. One from the wallet to unlock some tokens, and two to validate the minting script that you've created. And so I would recommend taking a look at that. Try to get that to work with a new policy, a different minting